In this last video for chapter 4, we're going to look at the formulas behind A and B in the line of best fit. And we're going to see how we can calculate those without using all of the calculator functions that we've seen so far. Thus far, we know that our line of best fit has the form y equals A plus bx, where A is the y-intercept. It's our prediction for y when x is 0. B is the slope. It's how much we predict how much we predict y to increase by as x goes up by 1. But we didn't see where those values came from. Our textbook states that we can calculate B, our slope, first if we take r, the correlation coefficient, and multiply it by the standard deviation of the y data set divided by the standard deviation of the x data set. That's where we can get our slope from. For A, that y-intercept, you find y bar, which is the mean of the y's, your values in L2. Subtract B, which we just saw how to calculate, times the x bar, that's your mean of your x data set. So this all goes back to the mean and standard deviation that we saw in chapter 3. Let's put this together with an example. It says, assume that in a stats class, the teacher only gives a midterm exam and a final exam. Those are the only grades in the class. Because we can't view the scatter plot, we're going to assume that the association between midterm and final exam scores is linear. We know that the mean of the midterm is 80 and the standard deviation is 8. For the final, the mean is also 80 and the standard deviation is also 8. R for this situation is 0.85 and N, our sample size, is 41. I want to know, what is the equation for the regression line? What is this y equals A plus bx? Well, I can't do what I've traditionally done because I don't have all 41 midterm scores and I don't have all 41 final exam scores. However, I can go back and use these formulas. In this case, I'm going to let my x as my explanatory variable be my midterm. And I'm going to let my y as my response variable be the final exam. This is because midway through the semester, we could use a midterm grade to predict how you're going to do on the final exam. It wouldn't make sense to try to use your final exam to predict your midterm, because if you've taken the final exam, then you've already taken the midterm. So we're going to use these midterms to predict the final exam. So midterm is associated with x, final exam is associated with y. We'll start by finding B. B is equal to R, which I know is 0.85, times standard deviation of y, that's the standard deviation of the final, divided by the standard deviation of x, that's the standard deviation of the midterm. And this will end up being 0.85. 8 divided by 8, that's 1, and 0.85 times 1 is just 0.85. You could use your calculator as well if you'd rather take that route. So just 0.85 times 8 divided by 8, and we get 0.85. So I know the B component of my line of best fit is 0.85. To find the A, we'll go to the other formula at the top of the page. A is equal to the mean of y, in this case the mean of the final, which is an 80, minus B, which I just found to be 0.85, times x bar, the mean of the midterm, which is also 80. So we'll type this into our calculator. 80 minus 0.85 times 80. And we get 12. our regression line would be y equals 12 plus 0.85x. I know A is 12, and I know B is 0.85. On part B, we want to know what is the predicted final exam score for a student who makes a 90 on the midterm. I'll plug in 90 for x in my equation. Be 12 plus 0.85 times 90. And that gives me an 88.5. So if we have somebody who makes a 90 on the midterm, the predicted final, it's not 100% guaranteed, that's an 88.5. Now, note the person made a 90 on the midterm, and we didn't predict a 90 on the final. We predicted a little bit lower. C asks, what statistical phenomenon is illustrated with this example? Well, going from a 90 to an 88.5 illustrates the idea of regression toward the mean. This person did really good on the midterm. They made a 90. That's above the average of 80. And we still predict them to do very well in the final, above the average, but it's a little bit closer to the mean. Regression toward the mean states that we expect values to get closer to the mean rather than moving further away from the mean.